Hello, pre-calculus student. This video is for chapter 4.5, log properties. There are three properties covered in this book, in this section. They call it rule. Sometimes we call it property, so it's just a terminology. In this book, called it a rule. So they call it product rule, quotient rule, and power rule. I should use R here, so it looks nicer. Generally speaking, what they're saying is if you have a log input that has multiple of two number or two expression, you can break it down into add. And if you have two things that is dividing inside the log, okay, then you can break it down as a subtraction. And then if you have m to the power p, you can move the p out as the exponent. And this is very powerful because it's very hard to manipulate things that are in the exponent. Like you can combine like term, you can, very hard to manipulate if it is in an exponent. But if you move it down as a coefficient, it's very easy to do. So let's look at why this works. It has to do with the fact that log is an exponent in an exponential function. So let's do a decimal graphing calculator. And if I would be doing log 2, it would give me a number. Log base, you can do any base. So in this case, it's log base 10. If I don't type anything, I can do log 5. Okay, so it's not particularly interesting. If I do log 2 plus 5, that obviously is not log 2 plus log 5. Obviously not the same. Okay, so log 2 plus log 5 is 1. Log 2 plus 5 inside is 0.8. So they're not the same. So you cannot split a log into like individual things. So first things you want to know is the properties of log. It's just like in general log function. If you are adding two number, is you can split them. You can just say, okay, let's do log 2 by log 5. But when I do log 2 plus log 5, we suddenly come up with 1. And if you look at log 2 and log 5 individually, because you can see that the value is actually, if you add them, they're actually 1. But if I log 2 times 5, it's also 1. Right? So just look at this. Earlier we say log 2 and log 5 are not the same, not log 2 plus log 5, but log 2, because this is actually equal to 1, this is actually equal to 0.8 something, 0.8 what? 0.84, yeah, 0.8, 1 decimal place, so they're not the same, so please don't break them. But when we're investigating these, we check that, well, if I multiply 2 plus 5 is 10, and it is actually log 1, and this means that it's equal to log 2 plus log 5. So it's not log 7, right? It's not equal to log 7, but log 2 plus log 5 is actually equal to log 10. These two are equal. So this is one special case of the, what is it called, the product rule. If you have two number all inside a log, doesn't have to be log 10. It could be log base, let's do another one, log base 3. So that's how you do log base 3. You can say 4 times 5. Oh, it's 2 plus 7. And then I'm going to the log base 3. What do you think it would be? Log plus log base 3, 5. All of a sudden, they're the same. Okay, you multiply anything inside a log or everything inside, you can split them up. Even if I multiply one more times 6, I will add log base 3, log base 3, 6. It still work, right? 4.35, 4.35. So anything that you have multiplied inside a log is just adding. The proof, you can, if you want to look at the proof, is in the book. they prove it here. So if you're interested looking at why, in general, it works with you. If you're doing log base bmn and you have m equal to log base bm and n equal to log base bn in exponential term, you write it back as this, and then you would come up with the proof. Okay, you can read the textbook. Okay, so let's for us, we are interested using it. So expand, we call this operation called expansion. I have one log. Everything inside is x, y, z. Oh, before I do that, I want to also make sure if you have log 2, and this whole log 2 times log 5 is not equal to log 2 plus 5. Okay. If you have 2 log multiply, Miss Chen, you say multiply become n. No, the multiply has to be within 1 log. Okay, so like here, I have log base b x, y, z. So we did once in the decimal calculator. It's the same as log base b, the same base plus log base b y plus log base b z. So these exponents add together is the same as you multiply them. Okay, so this is the answer, the expansion answer. What about condense? I want to condense it back. The wording they use is condense. It's basically a rewriting. Log space b x times x plus 1. Remember, it's all log 1 log times x minus 1. So be careful of the terminology. You have everything multiplied within 1 log. So that's done. Okay, you don't have to multiply it out. Example 6, expand. So this would involve, what is it called? The quotient rule. So if you have 2 things that are dividing, is the subtracting. 2 things inside 1 log is dividing, is subtracting. So I have 2x and y that are dividing. So I would do log base b, 2x subtract log base b, y. I can expand more because this is a multiplication. So that would equal to log base b 2 plus log base b x minus log base b y. Condense would be like group them all together, right? So and then they're all subtracting. So I would say log base b. So condense these 2 first. X divided by x plus 1 into one thing. Great. Minus log base b x minus 1. Okay, so this is still subtracting, so I have to divide it one more time, right? Log base b x over x plus 1, and then divided by x minus 1, whole thing. Okay, so can you manage if you have things like this? This is the same as log base b x over x plus 1 times the reciprocal of the multiple of it, right? 1 over x minus 1. So that means I have both of these in the denominator. If you do subtract both of these within the denominator, the only one in the denominator is x. You can rewrite it as nicer log base b x over x plus 1 x minus 1. You can multiply them or not multiply, is fine. Okay, so why are we learning this? This is used extensively in calculus to simplify some derivative operation, and also very often in a calculus work, after you do a calculus calculation, you have these, you have to condense them. The answer key generally would give the answer as 1 log instead of multiple log. So if you are to know how to read the calculus answer, you would know that, oh, how come I get this answer, but they give me this, they're equivalent. Okay, so, and it is advisable to write a calculus answer as 1 log. Example 7 is also a combination, is the power rule. Okay, let's look at power rule. Is log base b m to the 1 p power is equal to the coefficient multiply. So if I see log base 2 x to the 5, this is an exponent inside a log. I move it out. that would equal to 5 log base 2 x. That's it. That's expanding. What about condensing? Condensing would be if I see a 4, a number, not adding but multiply, I can move it inside as a exponent, x to the 4. Oh, log base e, I should say ln. ln is log base e. So ln x to the 4th. So not ln x or 4. Okay, that's not. They're two different things. What about 1/3? 1/3 can move in also. Will be log 2 x to the power 1/3. What is 1/3? Remember, is cube root. Okay, and also I want to mention this in general. If I have log base b to the x, we can think of it as moving the x out, and then log base b is 1. So this is the reason why log base b to the x is x. If you're evaluating something, if you have b and then b log base bx, it is also equal to x. And for this, why does it work? Is because of the inverse function. So if you do an exponent and then a log that is canceling each other, this is because of the log property. Okay, so this is useful for simplifying log expression. So if someone gives you log 6 and then 6 to the 3, then you say, oh, this 3, this 2 cancel. It's a log, and or you can say it move out. And then if someone say e ln 7, it's also cancel equal to 7. The next one is using all properties together. In the first examples 6 and 7, or 5, 6, and 7, we use power the product rule, quotient rule, and power rule individually. Now we are expanding a more difficult one. So condense. Okay, so this is, yeah, maybe I'll do another video for the more difficult example of using all log properties in the next video.